Hello everyone, my name is Elijah Proctor, and today we're going to be talking about two innovative concepts for visualizing relationships between variables. One is a scatter plot matrix and a heat map of correlations. And so this is useful for displaying data sets or visualizing data sets that have many relationships or multiple variables. And so first we're going to talk about a scatter plot matrix, or also known as a pair plot, which is used to examine relationships between multiple numerical values or variables in a data set. It displays scatter plots for every possible pair of variables, and it makes it easier to spot patterns and correlations. And so our data set that has multiple variables that we're going to be using today is the stat sheet for Team USA for their game against France, where they won gold. So we have their names, their points, their assists, their rebounds, and also the position they play on the court. We're going to use this object to create our data frame, and then our data frame is going to be used in our pair plot function in order to create the scatter plot matrix. And so we're going to also set the hue equal to position. And so by using color to distinguish player positions like the forward, the center, and the guard, this matrix highlights how different player types perform across various statistics such as rebounds, assists, and points. And for example, centers like Embiid and Davis are more focused on rebounding, while guards like Stephen Curry and Drew Holiday do very well or excel in points and assists. And forwards like LeBron James and Kevin Durant show balanced performances across all these matrices. So very, very interesting. So then we also have our heat map of correlations. This is used to visually represent the correlations between numerical variables in a data set, and it shows how strongly two variables are related. And how we're going to be creating the heat map is you have to first calculate the correlation matrix, which measures the relationship between variables like points, assists, and rebounds. And then you use the heat map function to display the matrix with the correlation values in each cell. And so if we look down, you can see we're using the same data set as we were using before. Team USA's stats against France. Store that in a data frame, and then once we have the data frame, we can use this correlation function on three of the keys from our data frame. We're going to use points, assists, and rebounds to find a correlation in this data. And then we're going to use plot to add a title and create the matrix from heat map. So we're going to use heat map, store a correlation matrix in there, set the annotate equal to true, the color mapping is magma, and then our line width is going to be 0.4. And so this heat map reveals key relationships. And example, players who score more points often also have more assists, indicating a positive correlation. And this is very common among guards and small forwards who handle both scoring and playmaking. And conversely, the correlation between points and rebounds is a lot weaker, suggesting that scoring and rebounding aren't strongly connected. And similarly, assists and rebounds show a weak correlation, reflecting the distinct responsibilities of those who playmake and those who rebound. So those are my two examples for data visualization. Thank you for listening.